Okay, I usually have a big enough mouth that I don't need one of these things. Plus, I hate the sound of my voice. It's horrible. I'm sorry. I'm sorry you have to listen to it. They actually say not to apologize at the beginning of a presentation, but sometimes you just have to when you have a voice as bad as mine. We've been working over the course of the last few months to develop a new high availability, basically fencing and recovery mechanism that would be generic across CloudStack. And obviously it's a big topic. We're not going to get into the deep details. In fact, the internal, the design we're working on right now that we'll be publishing as an FS very shortly is about 35 pages when you put together the design, the test plan, and everything else. So obviously in 20 minutes we're not going to go through all of that. The goal is more to talk about what's available to you as a developer with this new feature that we plan on delivering in time for 410 at the end of August. And so, all that being said, a very quick who am I? I'm the VP of Software Engineering at ShapeBlue. I'm a colleague of Paul, who you just talked with. I've been a member of the CloudStack PMC since the summer of 2013. Coming up on my anniversary there. What do you think about that? Previously, I've built clouds and actually run operation teams, developed provisioning infrastructures, as well as led software development for a very large-scale software as a service physical security platform. And I've also worked on developing NoSQL key value stores, high availability, as well as object stores. There are a lot of other people involved with this who unfortunately cannot be here today, but I wanted to make sure that they're included because I am just the tip of the iceberg here. Rohit, who I think everybody here knows, Abhi, Morley are all working in terms of development, and Bobby Stoynayev is also working on the testing end of this. I thought I was speaking into the mic. So, as I said, I want to give a quick shout out to those guys. They're actually working as we speak, as I'm having fun here giving a presentation. They are working on all of this. So all this started last October. Nux put in a ticket, and I've kind of just taken a few pieces out of it. Currently, KVM, don't usually read slides, but I think it's helps a little bit here. Currently, KVM HA works by monitoring an NFS-based heartbeat file, and it can often fail whenever this network share becomes slower, causing the hypervisors to reboot. This is embarrassing. How can we fix it? Ideas, suggestions. How are other hypervisors doing it? Okay, I'm here to not only give an idea suggestion, but also say that we have some code. So, and I want to present that idea and suggestion to you here right now. So, we do have HA in the system today. It is limited to hosts and VMs using NFS storage. Adding new storage types, it's tightly coupled. You would have to literally embed knowledge straight into that high availability manager about it. There's a tight coupling between the agent and the high availability manager. In other words, these two things have intimate knowledge of each other. So we have a certain amount of brittleness to it. And as Nux was alluding to, they're false positives. We will kill hosts sometimes that are perfectly fine. And how many people in this room have pulled an HA system out of production because it did that? I know I have. Thank you, GFS2. Fundamentally, you have to be able to trust. Correctness is the #1 thing we need out of an HA system. If you can't trust it, if it's going to go killing things that are or trying to recover fence and recover things that are actually healthy, it's got to go. Because then it's no longer high availability, it's bad availability. So when we first started this, there was a conversation, a suggestion on the mailing list that said, hey, why don't you look at things like Pacemaker or Linux HA? And we did, and the pros there, the pros of, the downside to the path we've taken is we are kind of stepping away from the, we're basically foregoing a proven battle-tested implementation. Linux HA has been out there for a while. These tools are out there in wide use. The problem we have is we have to teach that tool everything about CloudStack. So where we wouldn't be developing a lot of code in CloudStack, we'd be developing a lot of extensions in the Linux HA. We would have this kind of bespoke installation. Install a management server, install Linux HA. You'd have 2 sets of log files. You'd have 2 sets of instrumentation. That's just not a good experience for our operators. It's not really the CloudStack way. The CloudStack way is you get it, it works. And so we sat down and we said, you know what, at the end of the day, if we want to say we have a robust control plane, it should have a fencing recovery mechanism in it. It's just, should be part of the stock that you get. So we made that decision, and as we were looking at KVM and host HA, we said, well, wait a minute, there's a lot of very common pieces. We have this per resource FSM. We have persistence of all that state information. We have a concurrency model. We have a standard set of business rules that apply to every resource in the system. Why don't we create a standard service to manage all of that? Okay? That will work with any resource, whether it's a host, a VM, a volume, whatever you can come up with. And what you do, if you want to have HA for your resource, is you just create an HA provider specific to that resource type and that particular implementation. Where now we just ask you, the HA, that service asks just the basic questions as it's looking to do state transitions. Are you healthy? Do you have activity? Looks like you don't. Can you recover yourself? Can you fence? Is that resource currently eligible? So our goal there was to, first of all, address that coupling issue. We want a very, very loose coupling between resources and HA operations. And I use this term with caution because I don't mean it in the terms of aspect-oriented programming. But in our view, HA should just be an aspect that's added onto or bound at runtime to a resource. A host, a VM, shouldn't know it explicitly as an abstraction. Oh, I can participate in HA. We wanted to consolidate all those orthogonal HA concerns. Obviously, you need a robust threading model. You don't want these operations to overwhelm the management server. As I said, you have a standard state machine. You don't want to have to worry about persisting that information. When should the state transitions happen? All those things encapsulated inside of the service. We wanted to be able to prove that the operation of that service is correct. So that separation gives us the ability to build test suites, both unit integration test suites, that we can sit down and say, we know that the contract that we've put out works as expected. And when it doesn't, we'll be able to identify that. As we enhance it, as we grow it, we can do that with confidence. And we can give that confidence to our operators. We wanted it to also leverage all the existing CloudStack abstractions. People complain currently that, hey, if I want to do HA on Ceph, I've got to go make deep changes to the actual HA algorithms to make them knowledgeable of Ceph. I can't just leverage the fact that, hey, I've got Ceph out here with a driver, and I just want to, make it, allow it to participate. And finally, as part of this, knowing that we want to evolve the system, we wanted to embark on this in a way that said, how else might we do this with other things like this in CloudStack so that we can evolve the architecture without just stopping the train. In other words, CloudStack continues to evolve. And what we've done with this is that this new system sits side by side with the existing system and only replaces KVM host fencing. The system remains, the existing system remains in place, untouched for VMs for right now. So, a few very quick terms that we use, and will come up in the next few slides. Basically, there are 5 activities that the service is concerned with. Health checking, directly looking at that resource and saying, hey, are you alive? Are you good? This usually involves looking at the endpoint, saying, can you receive a ping, for example. An activity check is the observation of side effects when the health check fails to see that resource is actually functioning. Eligibility is, yes, I want that to be an HA, but is that resource currently in a state that HA can operate upon it? Recovery, okay, first 3 activities are idempotent. Should never make a change to the resource. However, recovery and fencing are, I think, what we would traditionally use in the industry. In terms of recovery, we want to take a resource that we've determined to be unhealthy and see if we can bring it back to a healthy state. If it turns out that we can't, we want to get it out of the way. That's fencing. I provide this slide more for reference when it goes up on, when I put this up on SlideShare. This is just a definition of all the states that are in the state machine. As I said, I thought for reference, people might find that interesting, but certainly with the time we have, and certainly with the fact that we're not going to go too deep in depth into the implementation, I didn't want to spend a whole lot of time on that. So this is the actual state transition model. Again, not something I'm going to really get into, but the point here is to show this is what's being encapsulated. This is what the service intends to give you, is this complexity encapsulated into a service that you can rely on and extend and have a stable extension point. So you can focus on what does it mean to health check? What does it mean to activity check? And you end up only implementing this interface in your plugin to affect the state transitions, to affect, these state transitions. Sorry. So there's your health check, there's your activity check. I want you to recover, I want you to finish. Are you eligible? We're probably gonna have a couple of other items in here. There's some parameters we need to get back from you about some timeouts and things like how long do you expect this to take? How long do you expect a fence operation to take? How long do you expect recovery to take? Things like that. But for the most part, if you have a plugin today that you're supporting and you have the ability to HA it, and I forgot to mention too that we do support multiple models. While we're doing a Stoneth model today for KVM, the HA service makes no assumptions about that. You might do Stoneth. You might do, recovery replace. You could do all kinds of models. HA service doesn't matter. You just these two operations and hey, go ahead and recover yourself. So how does KVM HA, how does that KVM host HA provider work? What's new? Well, we do the first thing we do is we do a health check right here down to the to the KVM agent. If we can't talk to the KVM agent, we have determined we don't have a healthy host. However, we all know the KVM agent can die and KVM can be running along just fine. So what we do after that is we go ask a peer node through the storage processor inside of the storage framework, can you look at the volumes, all the volumes that are on that machine, and see if there's any activity on one. By the way, that activity check is performed in a way, it's a watching check, so that you don't need clock sync across your cluster to make it happen. If we have activity, we're going to go up. That's a degraded node. Agent's down. There'll be alerts, obviously, send it out. I forgot to mention all the alerts and logic are all in the HA management service. If not, we're going to try to recover it. And we're going to do that recovery operation using the new out-of-band management features that are present inside of 4.9. So in this case, it'll be an IPMI restart. If we can't get a recovery, which by the way, that cycle is configurable, how many times you want to try that, we still can't get it right, we'll fence it. And in this case, fencing means powering off the host. And in all cases, alerts will be going through the standard mechanisms inside of CloudStack. The provider doesn't need to worry about that at all. So as I mentioned before, we wanted to make sure we had a robust concurrency model that you don't necessarily need to worry about in terms of when you're implementing a provider, but we wanted to make sure it was there. It's a producer-consumer model. All work queues are size-bounded. All operations are time-bounded. And all thread pools are fixed size. The goal here is, we do not want those operations overwhelming the control plane. Can't get it done in time, we're going to kill it. Idempotent operations are ephemeral. This means if you lose a node in your management server cluster, it comes up elsewhere. We might miss a beat, but we missed a health check. Not a big deal. Do it again, a little bit delayed. Non-idempotent operations are going through AsyncJobManager, but we're adding a new feature called a delayed dispatcher. So what the recovery and fence operations can say is, this is going to take at least 10 minutes, like a host restart. So don't check for at least 10 minutes. Maximum amount of time it's going to take is 15 minutes. So we won't sit there and just keep pulling and pulling away when it's worthless, when we know it's not going to be successful. So where do we stand right now? As I mentioned, we're heavily focused on the KVM host HA. We have started initial implementation to validate this design. We have a draft specification. We expect to put that functional spec out in the community within the next 1 to 2 weeks. We're working on a robust unit and integration test suite to validate the operation of that service. And we expect to get our PRN next month, and we expect to see this in the next release of CloudStack, which will be 4.10, which is tentatively scheduled for August, end of August. So finally, what do we want to do after all of this? We would like to support nested HA resources, so the understanding that a host has VMs on it that are HA'd, for example, so we can reason about, we don't want to go and do a recovery operation on a host if there are actually HA operations going on that contain VMs. We want to add deeper integration, instrumentation, so you can see what what's actually going on inside of that black box, as it were. And finally, we want to begin migrating the existing VM HA to this new service. So with all that being said, I think I got the 5 minutes. I got about 3 minutes left. Questions, comments? Please don't throw anything. I know I'm tempted to throw things at myself. Funds.
So initially, I guess this is going to be separated from the poo that's in there right now, right?
Yes.
Okay, so it's going to be an addition, so we can slowly migrate towards it as we should. Okay, cool.
Exactly. The idea is that we start out at the edges. We start with this, and then as it matures, we can pull it into the core.
Okay, cool.
That's what I was meaning in terms of trying to show here's a model that we can actually make things better without stopping everything and saying we got to rewrite the whole system.
Yeah.
We have to figure that out. It's critical for us to make CloudStack better.
Cool.
Bueller?
Any more questions?
I am posting on Slack to see if anyone has, but I'm so far.
Bueller.
All right. In that case, we will be breaking.